All right, now we're going to do number 6. So number 6 says a 65 kilogram crate, so that's our mass, is to be accelerated 7 meters per second squared up. So we're going to obviously make up positive when we do our sign convention. So A is equal to 7 meters per second squared. The angle is 25 degrees. If the coefficient of friction is 0.2, how much force is required? Yeah, this is going to be an applied force. You can call it FA. So the first thing we're going to do is we're going to draw our free body diagram with the forces going in the direction in which they're acting. So here's my box. We know the force of weight always acts straight down. Now this is being pushed up, so because it's moving up, I'm going to make my sign convention like this. Up is going to be positive, and then when I say up, I meant up the incline. All right, so now I'm going to draw all the forces going on it. So this is going to be my applied force going up. Remember, the tail always comes out of the center of mass. So on the FRQ, if you don't draw that way, they're going to only give you half credit. Now, if the box is moving this way, so friction's going to go opposite the way it's moving like this. And then my normal force always acts perpendicular to the surfaces in contact. So on an FRQ, you would actually get 4 points, 1, 2, 3, 4, for labeling these correctly in the correct direction and stuff like that. So those are 4 really easy points. And this is 25 degrees. So now we're going to look at this and we're going to say to ourselves, okay, which one or one forces is not going perpendicular and parallel to the surfaces in contact? And remember, this is the surfaces in contact. Okay, so the one that's not is the weight. So what I like to do is I always like to do it to the side so I don't make a mistake. Here's my weight, and then I'm going to call this one, I'll call this one FGY, because I'm calling this kind of my Y and my X. And then I'm going to call this one FGX. Remember, this is my 90-degree angle, and this is my 90-degree angle here. So these are similar triangles. This is just kind of flipped over. So this is my 25 degrees. So now I'm going to find the horizontal and vertical components. So FGY is equal to FG cosine of 25. Do I know FG? No, I have to find that. So I'll do that right now. FG is equal to mg, so it's equal to 65 kilograms times 9.8 meters per second squared, and that comes out to be 637 newtons. So now when I do this over here, FGY is equal to 637 times cosine of 25, so FGY is equal to 577. Remember, Y is cosine because it's adjacent to the given angle. So FGX, if I look at my picture, it's opposite. So FGX is FG sine of 25. So FGX is equal to 637 times sine of 25. So FGX ends up being 269. Whoops. So before I do anything else, I'm going to redraw this, and I'm going to have all my forces going both perpendicular and parallel to the surfaces in contact. Once I draw that picture, then it's easy. There's 3 things I know I'm going to do. I'm going to sum forces horizontally, I'm going to sum forces vertically, and I'm going to use my mu equation. And if you do them in the wrong order and you're like, oh, I don't have enough stuff, you do something else and you come back to it. All right, so here's my diagram. Again, I want to show my sign convention, because that's important. You know, my applied force doesn't change, it's acting up. My frictional force is opposite the motion. My normal force is perpendicular. And now instead of Fg, I'm going to have Fgy, and I'm going to have Fgx. Now this is very, very, very important. When I draw this picture here, you see how I did the components of the weight? So remember, the components act head to tail. So this one goes down, and then this one ends up going down the incline. And this is very important that these are drawn in the correct direction, so when I put them here, they're drawn in the correct direction. So I'll start summing forces, I guess, vertically. I know my box isn't even accelerating, so that's always a good one to do. So summation of f of y is equal to ma. Is this accelerating in this y direction? No. Now remember, this is my y and this is my x. So this is 0. So in my y, I have fn, which is positive, minus fgy, which is negative, and that's 0. So f of n is equal to fgy. So f of n is equal to 577. Now, if I sum forces horizontally, that's where my applied force is. But I'm not sure if I have everything that I need in that, because I know I don't have f of f, and I don't have fa. You see how there's two unknowns there? So I could do that last. If I don't do it last, and I go ahead and write it, and I'll just go ahead and do it. So let's say I did that next, and I said summation of f of x is equal to ma. Now when I look at my diagram, fa is positive, minus f of f, minus fgx. And the bad thing about high school physics books, they'll just put this out, and they'll say, oh, magic working equation. It's not magic. You get this. Remember, these three things, and I should have done it underneath, this is this. These are the forces that I added up going in the direction. Now, it is accelerating. The problem here is I have two unknowns. My two unknowns are fa, which I'm solving for, and then I don't know f of f. So I have to find f of f. So let me go ahead and do that. And that's the mu equation. Mu is equal to f of f over f of n. So f of f is equal to mu times f of n, which is going to be 0.2 times the normal force, which is 577. So f of f is equal to 115. Now I can go ahead and substitute it back in this equation. So now I'll go back to that, and I'll say ma is equal to fa minus ff minus fgx. I would go ahead and rearrange the equation so I don't make a sign mistake. So I'll go ahead and, or you could just substitute in your values. But remember, I want to solve for fa, so I'll just move everything on the other side of the equal sign. So fa is equal to ma plus f of f plus fgx. So that's equal to the mass, 65 kilograms, times the acceleration, 7 meters per second squared, plus f of f, which is 115, plus fgy, oh, this is fgx, plus fgx, which is 269. So when I add that all up, the applied force comes out to be 839 newtons. So again, step by step by step. And that's it. So these really aren't that difficult, but again, you need to first draw your free body diagram, break your forces up going perpendicular and parallel, and then there's three things you're always going to do. Some forces horizontally, some forces vertically, and use your mu equation.